Assalamualaikum and very good morning. Today I'm going to discuss about the assignment. First of all, I'm going to tell you guys about the objective for this assignment. First, to calculate the phase angle between voltage and current. Second, to observe the result of calculation and the result of simulation. Okay, next I'm going to pass to Sureng.
Hello everyone, my name is Surinder Laki Bhaskar from group 9. So now I'm going to start my presentation. So first of all, we must build a circuit which has been stated in the SEM1 given on a software called Protus. So first of all, we need to place the V sign and then followed by the resistors, another one, and inductor, and then a capacitor. We rotate this first. Sorry, capacitor, rotate this and we place it. Okay, and then we connect the circuit using the wires. Something like this, and then ground terminal over here, place around somewhere around here. It's placed in voltage and current. Okay, okay, now we need to rename all these components. Click here, set amplitude 50, frequency 50, show all, okay, and then we rename this to SEM1, V, and this current as I. And then the value of resistor, which is 10 ohm. The first one, 10. The second resistor, 5 ohm. the inductor, J5, capacitor is negative. Sorry, we just put J10 because we can't put negative in this. So this is our question, and now we need to find the answer for this. So before that, go and see our calculation first. Okay, this is the objective, and this is the circuit. Our question. This is the calculation to find L1, which is inductor, and also C1, which is capacitor. The actual value given for L1 is J5 ohm, and for C1 is negative J10 ohm. To find XL is equals to 2 pi FL, and XC is equals to 1 per 2 pi FC. So we convert this equation into this, and this equation into this, and then we just substitute the values given into the formulas, and we will get the value for L1 and also C1. Okay, so we go here first, change our value of L1 first, which is 0.0159, and value of the capacitor is 3.18, sorry, 318.31. Okay, connect it. Sorry, okay, connect it back again. Ground terminal. Okay, done. So the next step is we need to sketch. We need to generate a graph, the analog graph, some something like this. Okay, then we right click over here, press add traces, IP1 root P. Okay, we simulate the graph. Okay, we need to edit it, change the stop time from 1 to 0.1. Yes. Okay, this will be our V graph. The V peak value is 50. Okay, and we straight away add another trace for I, which is current. Okay, simulate it too, and we'll get an I graph, something like this. Okay, so now we go back to the work. Okay, over here. Okay, let me check with this. Okay, the values are correct. Okay, done. Go back here. Okay, from the calculation, you know that total impedance, all this, to find the total resistance of the circuit, need to plus these two resistors, this inductor and also this capacitor. So to find the total value, total up all of these first. The R value, R1 is 10 ohm, R2 is 5 ohm. The impedance value 5J. The consistor value -J10, and then we will get like this. And to solve this this value to become an integer, we need to use some of these formulas. Actually, this some of the basic formulas that we have learned before in our secondary schools. First of all, we need to find the magnitude of Z. To find that, we must use this formula. We just substitute. We must know that the 15 is X and -5J is, -5 is Y. Sorry, come again. 15 is Y and 95 is X. So we just substitute the value in this. We'll get the value of magnitude Z, and for the theta's value, we must use this value tan 91 y to x, the same values y and x. substitute, and we will get 95.435 degrees. So this will be our Z value, and our V value is this. You can clearly see that already stated in our question. V is equal to 50, and so to find the current, we know the formula is I equals to V per Z. We substitute the value of V and we substitute the value of Z. We calculate and we will get this value. This is the value of I. And one more thing, by referring to this graph, you can clearly see that the circuit is full and full a capacitive type of circuit, because you can see that the I leads V. Yes, I leads V by 18.435 degrees. This is not pure capacitance actually. Pure capacitance is 90 degrees, and pure inductance is 90 degrees too, plus minus, and pure resistance value is 0 degrees. So this is our calculation value, and this is the just now we saw, right, the circuit after we fill in the values that we found just now, and the graph. You can see here the peak value of V is 50 and peak value of I is something. If you zoom in, you can see that 3.16 something will get 3.16 ampere, voltage peak 50 ampere, and when voltage is at peak, the time is 20 millisecond. Over here we take this part, 25 millisecond, and this moves slightly before which is when the current peak value is 24 millisecond, and then if we calculate the time difference, which can be found by substituting voltage peak time and current peak time, so we'll get 1 millisecond. The phase angle between I and V, to find it through simulation values, is we multiply frequency to the time difference, and the angle of 1 cycle, which is 360. So 50 Hertz times 1 millisecond times 360 degrees, which we will get 18 degrees. And we can conclude that as a comparison, we can say that the calculation result and the simulation result are almost the same. And we also answered the questions which has been asked in our assignment. So that's all from me. I'll hand it over to my groupmate Wani, and thank you.
Okay, for the discussion, for this assignment, the circuit is constructed using figure 16, which is this figure. Okay. The values of the inductor and the capacitor are calculated using the formula XL equal to J omega L and XC equal to 1 over J omega C. So, here. But I already told you guys, XL equal to XL equal to omega L. But this formula XL equal to 2 pi FL. So that means omega equal to 2 pi F. So XC equal to 1 over 2 pi FC. Okay, let's go fast. So we look at the circuit. A value for amplitude and frequency are already given in V sine, which is 50 volts and 50 hertz. This one. Okay, this one. V sine, V amplitude 50 volts, frequency 50 hertz. Okay, next. Based on formula V equal to IR, we can get another formula to calculate current, which is I equal to V over R, where R equal to Z is used to obtain the current value. A graph of current and voltage is present in analog analysis, which is this one. This one is present in analog analysis. Okay. The angle between current and voltage is determined by a formula that takes the total time of one complete cycle and multiplies it by 360 degrees. As a result present in the graph, a voltage current graph shows that the current is leading the charge by 18.435, which is this one. I leads V by 18.435. Okay, which is because the reaction size of the XC reaction is larger than the XL and makes this circuit as capacitive circuit. The percentage difference between the measured values and the estimates for the current and voltage phase angles were 0.027% and 2.36% respectively, which is this one. Okay, so let's move to our last part, which is conclusion. As a conclusion, to run the whole RLC simulation, we use a software called Proteus. For calculation, we use some formulas such as XL equal to 2 pi FZL to find the impedance of the induction, and XC equal to 1 over 2 pi F XC. That I already told you guys before, to find the capacitance of the capacitor. Phase angle between I and V is 18 to 18.43 based on the calculation and simulation. We can also see that I leads V by 18.43, and as a proof, we can refer to a graph form, which is this one. That's all. Thank you.